Hello, and welcome to Lesson 3 of Unit 7, Special Exponential Functions. In our last lesson, we went over solving exponential functions, and that's what our warm-up is. I'd like you to try to pause the video and try it on your own. If you need a refresher, this is what we're going to do. What we would want to do for this warm-up is that 64 is in the bottom, so we're going to send it to the top, and we're going to have that, that exponent become -1. So we now have to see about getting like bases. I'm going to distribute that negative in so that way I don't have to worry about it later. The reason is that 64 can be written as 4 cubed. So what we end up with, nothing on the left side's changing, but we get 4 cubed is 64 times the exponent that's already there. So when we have this the same bases on both sides, we can set the exponents equal to each other and solve. And so when we distribute in, we would get 3x minus 2 equals -6x plus 15. I'm going to add 6, so I get 9x. Add 2, I get 7. So x equals 17/9. And it's okay that it's a fraction. Again, you can plug it in and check, or you can accept it and move on. Okay, so what we're going to be doing today is we're going to be looking at a special type of exponential function. It is working with e, base e. Now, e, it is an irrational number that approximately equals 2.718281, and it'll keep going on forever and ever and ever. That's why it's called, an irrational number, because it cannot be written as a fraction. So the number e is an irrational number that has an exponential relationship and is used in calculating finance problems. So other irrational numbers like e are like pi, the square root of 2, and so on. We can use our calculator to find e. So on a TI-30X, that's what we have in class, so hopefully you picked up a calculator. If you didn't, please, please, please go pause the video and go pick up a calculator, because you need to know how to find these buttons. So what we're going to do is we are going to actually calculate e. And so how to calculate e on a calculator, you're going to press second ln. What's going to happen is it should have something that looks like this, e caret, and then it'll automatically give you a parenthesis. We're going to put 1 for our exponent to find out, because anything to the first power is itself. And what we get is that really long number that's in our definition at the top. 2.7182818, and so on. And so, since e is just a number, kind of like pi, we can apply our exponent rules and many other rules that we'll see in today's lesson. So, for e with our exponent rules, kind of like what we've seen, is when they're apart, we add the exponents together. So 7 plus 5 is 12. There you go. Okay, for b, so 40 and 14 both have 2 in common. So we get 20 and 7. Okay, those have nothing else in common. Now we have e to the 7th over e to the 5th. We're going to be subtracting from the bigger exponent, which is on top. So 7 minus 5 is 2, giving us our final answer of 20e squared all over 7. Okay, our next one, we have that negative exponent. However, because they're apart, we're just going to add them. And 6 plus -4 is just 2. Now, you got to be careful. We're not doing 4 plus 5. We're doing 4 times 5, which is 20, to get 20e squared. That looks a little funky. Let me fix that. 20e squared, because it should all be on the same level except our exponent. Now, our last one, we're going to distribute that 4 in. Now, some of us are forgetting that numbers are bases. And so we would get -3 to the 4th power e to the 2x times 4, because it's a power to a power. And so -3 to the 4th power, it's to an even, so it'll be positive, is going to be 81 e to the 8x power. And there is our answer. So going to the next page, we can graph e to the x power. This is going to be our parent function. We will transform it. Now, because e is an irrational number, we get a couple problems. So we got x and y. We're going to plug -1, 0, 1, and 2 in to our calculator. And so what we're going to do is we are going to get y equals e to the negative first power. And so that's going to be e caret -1. And what we're going to get is 0.36. Now you can plug e to the 0 power. Well, again, because it's a number, anything to the 0 power is 1. And then we're going to do y equals e to the first power. Well, we just found that, and it's going to be 2.78. It's going to keep, what is it? 2.7182, blah, blah, blah. So let's just write 2.7 for e's to graph it, and that's what this is going to be a little bit difficult. And then we're going to finish with y equals e to the second power, which will be 7.39. So I'm just going to round it to 7.4. So what happens is we can kind of tell our numbers aren't going, we're not adding, we're multiplying. That's why it's a special exponential function. So when we graph these, we got -1, 0.36, 0, 1, 1, 2.7, and then 2, 7.4. So that creates our function. Now, because it's an exponential, we have a horizontal asymptote. Well, our horizontal asymptote, just like exponential functions, is that vertical shift, and so it's going to be at 0. So when we connect them, we don't want to cross that x-axis. Our graph is going to look like a normal exponential function. It's just that instead of having nice lattice points, we're going to have decimals. And so our horizontal asymptote, remember it's an equation, so it's going to be at y equals 0. Our y-intercept we can tell is at 1. Our domain is -infinity to infinity, and our range is our horizontal asymptote to infinity. It's still going to have that parenthesis on it because we are never going to get to 0, as we can tell by the fact that when we plugged in a negative number, we didn't go over the x-axis. So all the exponential function rules apply. Okay. So what we're going to do is we're going to talk about transforming this function. What's cool is all the same rules apply. So this a, that is our vertical stretch or shrink by a scale factor of a. We then have that minus h. It's inside the exponent. That rule still applies. So that's going to be our horizontal shift, and that can be either left or right. And then finally, our last one is going to be that k value. That's going to be our vertical shift up and down. So all of those same rules apply. So what we're going to do now is we are going to look at base E transformations. So we can still verbalize all of our transformations. I'm going to highlight to help color code. So that first one, that is that vertical stretch by a scale factor of 2. We then have that +3 that is in the exponent. And so you can write, if you want, horizontal shift, because it's inside. But what I'm really looking for, because it's the opposite, left 3. I'm really just looking for that left 3. Finishing with that -4 that is outside. So again, you can write, if you want, that vertical shift. But because it's minus and it's going to stay the same, it's going to be down 4. And again, that's what we're really looking for. And so this vertical shift is going to be our horizontal asymptote. So y equals -4. So I'm going to draw that in so I know where my graph is approaching. And now I'm going to take my table from above, because that was my parent function. I'm going to write it right here. x, y. I'm really just going to do 2 points. I'm going to do that 0, 1, and that 1, 2.7. If you want, you can do one more, but you don't have to. And so I'm going to apply everything. I'm going to multiply by 2 because it's outside. I'm going to subtract 3 because it's inside. And then I'm going to subtract 4 because it's outside. And then we get -3, -2. Going to the other side, we get 2 and then 5.4. Again, it's okay to have decimals because e is irrational. And so from here, we're going to get -2 and 1.4. So we have those 2 points that we're going to graph. So -3, -2, and -2, 1.4. This is why that asymptote is really nice, is that we can draw our graph, and it's going to kind of look like this. It should kind of have a little bit more of a curve. It should look more like that. But because it's such a vertical stretch and it's exponential already, we don't get to, it would be really difficult to see the next point. So that is our graph. Our domain is always -infinity to infinity. Our range is our asymptote, so -4 to infinity. Now our y-intercept, I'm going to do some work over here. A basic y-intercept is always 0, 0, y. Now, in this problem, we don't see it in our table. So what we can do instead is we can take our function and we can plug 0 in for our exponent, for x. And so we get 2e to the third power minus 4. Now we can plug that into our calculator. 2ex, it's automatically going to give you this. Don't forget that extra parenthesis because we need to end it to tell the calculator that minus 4 is not in the exponent. And I've gotten 36.2. And again, the reason that we're getting decimals is because e is irrational. Okay? So that is graphing transformations. We also simplified e base e. The last thing the second to last thing we're going to do is solve equations with base e. Same rules apply. So when they are the same bases, we set those exponents equal to each other and solve. So when I subtract x from both sides, we get x equals 3. So there's our first answer. And then going over here, we have bases that are alike on the same side, so we're going to add their exponents. So we get e to the 3x plus 2 equals e to the 12th. Same basis, so I get 3x plus 2 equals 12. I'm going to work on isolating that x value, and I'm going to get a fraction again of 10/3. And so there is how we solve, same rules apply that we saw in our warm-up. The last thing we're going to talk about is compounded continuously. So in our last lesson, 7.2, we talked about compounded interest that is like compounded quarterly, monthly, annually, and our formula for that was A equals P times 1 plus R over N to the NT. That was our compounded by a certain time. Now what we're going to do is we can compound continuously, which means that every single moment of every single day, it is calculating your interest or how much money you're earning or owing, depending on if it's a savings versus like a credit card. And so what we have is very similar pieces. So A, the amount in the account, we've seen that before. P, principal, we've seen that before. Rate, seen that before. Time, seen that before. What's going to be different is how it's set up and the fact that we're using base E in our formula. Personally, I like this one, or this type of formula a lot better. So Lucy deposited $1,500 in a savings account that pays 3% annual interest compounded continuously. When we see that word continuously, we should want to think this formula. And so what we're going to do is A equals our principal, same rules apply, what we're starting with, E to our rate. Now we want to turn 3% into a decimal. So we want to go 1, 2 over. So in our exponent, we're going to have 0.03 times our time, which is 4. And so we can plug that straight into our calculator. 1 1,500, no parentheses, second ln, which will give us our e, so 0.03 times 4. And what we get is 1691.245. And it's going to round to the nearest cent because we're working with money. And so that 5 is going to tell us that we're going to round up to get, don't forget our units, $1,691.25. Okay. Now, why don't you pause the video and try B? If you don't feel that comfortable, this is how we do our problem. So it's very similar to what we saw above. The only difference is that our time is now 10. And so when we plug that into our calculator, we're going to plug 10 in for our time, and we get 2024.788. And so we're going to, again, round up for this problem. So again, don't forget our units. $2,000.24, $2,024.79 to get our final answer. And that is base E. Woo! Okay, come to class with your questions. I hope you understood it.